Look at this exam calculation. 10 spaces times 1/50th of a second equals 0.2 seconds. Distance is 5 centimeters. Speed equals 25 centimeters per second. The math, absolutely flawless. The score? 0 out of 3 marks, slashed by the examiner's red pen. Why? Well, today we are mastering motion, ticker tape timers, and the exact top mark strategy for Cambridge IGCSE Physics 0625, so this literal nightmare never, ever happens to you. This exact ticker tape calculation costs around 60% of Cambridge physics students their A star. The math is right, but it scores a big, fat 0. Why? Because you see, Cambridge physics isn't just about blindly punching numbers into a calculator. It's about scientific reasoning. It's about units. And it's about proving beyond a shadow of a doubt that you actually understand the physical experiment taking place. So let's dive into this. The reason so many hardworking students fail to get full marks is because ordinary revision completely fails them. Ordinary revision just traps you into memorizing formulas without understanding how to actually apply them. You walk into the exam hall thinking you're prepared, but you step right into the revision trap. I'm talking about missing units in your final answers, rounding your calculations way too early, writing super vague explanations of motion, plugging in the completely wrong variables, or, and this is a huge one, making broad conclusions that simply are not supported by the data you collected. Trust me, the examiner's red pen is just waiting for you to make these exact mistakes. But don't worry, to beat these traps, we need a reliable system. Let's look at how we build our top mark framework. This is your new mandatory 4-step method to guarantee full marks on literally every describe or explain question you face. Step 1, state the concept. Step 2, provide the evidence or data extracted directly from the experiment. Step 3, apply scientific reasoning to connect that data right back to the concept. And Step 4, use the exact examiner wording. Master this framework and you are going to bulletproof your exam answers. Now, you're probably wondering what that specific magical examiner wording actually looks like, right? Well, in a moment, I'll show you the exact examiner wording that flips a rejected conclusion into a top-band answer. But first, you need the 4-step framework that makes that wording obvious. Because honestly, if you don't fully grasp the experimental setup first, having the right words just won't save you. Okay, let's start applying step 1 of our framework, the concept. In our source material, average speed is strictly defined as the ratio of the total distance traveled to the total time taken. This right here is your foundation. When an exam question asks you about a trolley moving down a runway, you don't just write, oh, it goes fast. No, you anchor your answer in this exact mathematical ratio. That is exactly how you secure your very first conceptual mark. Next, I want you to focus your attention on this single vital fraction, 1/50, 1/50th. If you're using a standard ticker tape timer plugged into a power supply, that timer makes a dot or a tick on the paper tape every 1/50th of a second. This is the invisible baseline of your time data. Forgetting this tiny little fraction completely destroys your calculations, because without it, you suddenly have absolutely no idea how much time has passed between the dots on your tape. So how do we practically gather our evidence? This is step 2 of our framework. First, you pull a length of tape through the timer while it's attached to your moving object. Then, and our source strictly advises this, you cut the tape on every 11th dot. Why the 11th? Because that gives you exactly 10 spaces between the cuts. 10 spaces at 1/50th of a second each gives you a highly workable, clean time interval of 0.2 seconds per strip. You then arrange these successive strips side by side to make a tape chart. Oh, and a crucial safety note straight from the syllabus to protect your marks and, well, your toes. Ensure that the trolley does not fall from the end of the runway as it could cause injury to your legs or feet. Seriously, do not skip these safety points. Examiners absolutely love testing them. And this brilliantly illustrates how we move to step 3, scientific reasoning. Let's look at a tape chart analysis. When you arrange your 10 tick strips side by side so the bottom of each is on a flat horizontal line, a very clear pattern emerges. If they are all equal length strips, your scientific conclusion is constant speed. Why? Because the distance traveled in each 0.2 second interval remained exactly the same. But if you see increasing length strips, well, the distance covered in that same exact time interval is growing. Therefore, the conclusion must be increasing speed.
Which brings us to an escalation in difficulty. If speed increases, an object is accelerating. According to the Cambridge Livius, acceleration is the change of velocity divided by the time taken for the change, formally written as A equals delta V over delta T. We aren't just looking at flat speed anymore. We are evaluating the rate at which that velocity is actually changing over our time intervals. This is where the stakes get much higher in your exam paper and where vague answers get ruthlessly punished.
So let's test this out with a quick interactive challenge. Try to spot the error here. An exam question asks you to explain how the ticker tape shows acceleration. A student writes, "The spaces on the tape are getting bigger, so the trolley is accelerating." Take a few seconds right now to think about it. Got it? Why does this answer lose marks? I mean, it sounds intuitively correct, right? Bigger spaces mean it's going faster. But put your examiner hat on and apply our 4-step framework. What critical pieces of evidence and scientific reasoning are completely missing? All right, the crucial point here is the precision of your evidence and your wording. Let's look at the flawed answer first. Spaces get bigger, so it accelerates. It's just lazy and way too vague. Now look at the top band answer. Distance between ticks increases over the same 1/50th of a second interval, showing increasing velocity, proving acceleration where A equals delta V over delta T. Do you see the massive difference there? The top band answer specifies the exact time interval of 1/50th of a second, it references velocity instead of just saying bigger spaces, and it ties everything mathematically back to the acceleration formula. It uses our entire framework to build an absolutely undeniable case. Listen to this brutal, direct feedback right from the examiner's correction notes. Conclusions must be supported by data. Vague explanations score 0. Always state the time interval. If you just say, spaces get bigger, that is a vague explanation. You haven't proven to the examiner that the time remained constant. By explicitly stating the 1/50th of a second interval, you prove that more distance was covered in the exact same amount of time. You lock in that mark. This precision? That is the exact examiner wording I promised you earlier. But here is the final, somewhat uncomfortable truth about your exams. Knowing this 4-step framework is entirely useless if you freeze up and fail to execute it under strict exam time pressure. You have the knowledge now, but do you have the speed to write it perfectly when the clock is ticking down? Your next mandatory step is to master the timed answer writing system. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. You need to jump into the next explainer right now to build that exam speed muscle, because knowing the perfect answer doesn't matter at all if you run out of time to actually write it down. Are you really going to let the clock steal the marks you've rightfully earned? Take the red pen rescue route to the next explainer, and I'll see you there.